Hi, Mike. How are you?
Hi, I'm doing good. How are you?
Hey, this Steve just joined. Hi, Steve.
Mm-hmm.
Welcome back, Steve. I guess he's
Hey,
still
Steve.
in the. There he is.
Oh yeah, how's it going?
Good. So I wasn't able to get much done. I had like relatives visiting from India and stuff, so it was like a packed week, and we have like you've joined twice, Steve.
I have.
We have a duplicate, Steve. Anyway, there you go.
Oh,
One of your
hopefully
twins dropped off.
hopefully I'm only in once.
Yeah, you're on one now. So I didn't
Yeah,
get much done other than, I noticed the same notebook that you pointed to, Steve, of because I was trying to do it in a very complicated way that we discussed last week. But I think the way the guy in the notebook you pointed to did it was, I think, quite smart. You can just drop the duplicates and pick either the first or the last, and then use the appropriate slice using label ID and appropriate offsets and stuff. So I did that. I just, in fact, because I couldn't do any work during the week, relatives, I just dropped them off this morning. So I was able to submit one EEG score, and the EEG scores are definitely better than the corresponding ones when you take the midpoint and that kind of stuff. So the one variant that compared to what you had mentioned earlier, Steve, and I don't know whether you had already modified your approach for that difference is last week also, Raquel, when he joined, that pointed out that it could be the case that the consensus remains the same while the underlying distribution changes a little bit, and I wasn't sure whether that really happens. But as I was using the guy's notebook, I tested a few values, and sure enough, it happens that the distribution changes by 1 vote, plus, minus, and a couple of votes and stuff like that. And in those instances, the consensus doesn't change, but the votes do, the underlying probability changes. And since you're predicting probabilities, it's better to retain those values when as probabilities rather than just picking based off of expert consensus. So that's what I did.
yeah, my original data set, I did what you just described there. Like, if the vote stayed the same, then I kept it. Like the same, where his is better because of the fact that like he changes it per vote. The only thing I would say about his is the fact that like I think he still takes, you'll take the first row. I think that when the vote sort of stays the same, he takes the first row of that, and so you may have I don't
Right.
know, five or six in a row, and he takes the first one. So it might be better to take the middle one of those, but I'm not sure how much difference that
Yeah,
would
the
make.
question I had there, so what I did was I used the last one. I changed the first to the last because you can do that. When you drop, you can just say, give me the last one. So I changed first to last, and I took the last one. The question I
Right.
had with the middle choice that you mentioned is, how do you pick the middle? Because if the number is even, then aren't you picking a point that where the middle 10 seconds are not actually indicative of that whatever
Yeah.
that class?
Yeah, you are. I actually found that. Yeah, so like like I was like setting it up like Chris Diot does to find like the minimum and the maximum offset. And then I was like saying like, yeah, like, I can take the median. But yeah, as you say, like, if there's like an even number, then it ends up like picking a row
Right.
between the minimum and the maximum, which may not be like something that's been sort of voted on. So yeah.
Yeah, that hasn't been classified, right? Yeah,
Yeah.
that's what we
so
were. At least that occurred to me. That so I was wondering how you did that, because if it's odd, then you will land on a row that's perfect. But if it's even, then you have a problem, because it's not an actual point where the data exists that supports the class. I mean,
Yeah,
of
so
course, you could, by taking 50 seconds, you could.
yeah, I'd found that myself, and so yeah, but yeah, I've changed now just to use that guy's data set that I pointed to. Like, yeah, so
Which
he
notebook are you guys referring to?
the
one
one I
that
put in
Steve
Splasher in a
posted.
week.
Okay, okay.
It's like it's called spectrogram from unique EEG votes combo.
Mm-hmm.
And yes, so like what he does, he basically just, when the votes stay the same, he combines the rows. And so yeah, so that drops it down. Like, he drops down from whatever it is, 100,000 in the original training CSV file down to about 20,000. And then he creates like a spectrogram from the EEG per row. But it means like if the vote changes across a single EEG, then he'll have several spectrograms for that.
Mm-hmm.
Yeah. So he generates or uses an additional 3,094 EEG additionally, compared to the 17,089 unique EEG IDs. So by picking additional rows where the votes are changing, he gets an additional 3,094 EEGs. And I also did that for SPECT, by the way. And the SPECT, if you do the exact same thing for spectrograms, they generate an additional. So the unique spectrograms are 11,138, and these, using anytime the vote changes, generates like 4,869 additional spectrograms, if you will. And I trained with that, and obviously that gives a better score too. So any ensembling of these is definitely going to give you a better score. So that's definitely a good, excellent approach. And the thing I liked about it was I was struggling. I mean, in fact, the approach we took, that I took, I don't know, maybe Steve was, I'm sure Steve was smarter than what I was doing. And I was doing this stupid approach of taking, whenever the expert consensus changes, and then like going back one row to when it changes, because I wanted to pick the last row, instead of just using what he does, which is drop. When you do that, you kind of completely lose any parallelization benefits that pandas gives. So believe it or not, when I ran it on spectrogram, and that was taking like 4 hours plus, and it still hadn't finished. So I was like, oh, there's got to be a better way to do this. And that's, and after last week's meeting, when I poked around, I saw this notebook done it in a much smarter way. So, and Steve also posted it just about when I started working with that. But that notebook also does a couple of things, Steve, that I haven't yet, as I said last week, was pretty wasted for me, but that I also think are fairly interesting, right? Because the new discussion that has emerged, and I haven't yet gone through it and understood it myself fully, but the new discussion that's emerged, I don't know whether you're already up to speed on that, but I'm not. I'm just trying to. This week I'll probably do quite a bit of work, but the concept there that people have pointed out is that apparently the data set that we have is a combination, they believe, of two data sets. One which has a small number of votes from the doctors that generates the expert consensus, like less than 7, or something like that, 7 votes or something, and then there is a whole set that does much larger number of votes, or 28 or something like that. So have you kind of caught up on that discussion, and how they are therefore kind of a bunch of people are doing like a 2-step process where they classify the data into scale divergence of less than some value, and then use that data to train a model, and then use I believe, I may be wrong about the detail, but they then extra train that model with a different value of scale divergence. Have you kind of looked into that approach?
Yeah, so can you see my screen? Sorry.
Yes.
Yeah, we can.
Yeah, so I've been working like on this notebook this week, and like this notebook, yeah, so like it uses the data set we've been talking about, the one that has multiple spectrograms per EEG where it changes on the vote. But yeah, like as you say, yeah, so this one here, it's got like this one here, most of the notebooks that are out there at the minute, the top ones, they're all ensembles or whatever, like of like sort of 4 or 5 different things. But this one here, this notebook, like it achieves like 0.36 all by itself. So I've been working with this one, and yeah, like so it's got like a few interesting things in, like it's got the thing you're talking about there. Yes, like down its training loop, it does training twice. Sorry, yes. So I'm not sure. Yeah, so here.
Yeah, this
yes,
one.
Yeah, so like this is loading the standard Kaggle training set. And then yeah, like it's like showing this graph here. So like it's like saying, yeah, like whatever. Most of the data has like only very few experts or whatever making the vote. And then there's like this other set. And so like when it comes to train, it trains in 2 goes. It trains yeah, the first one. Yeah, the first training loop here, I think it only trains on, yeah, like if it's got like less than a certain number of people voting on it.
7, I think the cutoff is, if I remember.
Yeah, and then the second time, yeah, so like if it's got
I guess
sort of
greater than 10. Yeah.
More than 10 people, then it trains it again. Yeah, so like it is what you were talking about. But the other interesting thing it has, which I'm not entirely sure about, it does a funny thing where it adds
adding the 0.166.
Yeah, so I don't know what that's all about, but
yeah, that was something. Yeah, so I chased some discussion down again. Like I said, I was like on and off. I didn't work too much. Exactly, in fact, where you were previously, because you add the 0.16 to the 0.16667 or whatever. Basically, whatever you get, no 0.1. If you do that,
what's that adding stuff?
Yeah.
Okay.
Right,
Okay.
So yeah, to the target. So in fact, like, the one thing I took away from it is it's more to give your CV scores, or more to indicate that your CV scores are more accurate representation of the leaderboard than actually helping you get a better score. That's what eventually I concluded. So it doesn't improve your score as much as it gets your CV scores to be better indicators. If you go back to where you were previously, Steve, the link, I kind of chased a couple of those links, because that link, here he says, as stated here, and there is some discussion, and as you see, it just says bridging the gap between CV and leaderboard scores. So it just seems to be an adjustment, but I can't. In fact, I was going to ask if you, and maybe we can do it all. All of us can look at it and come up with. I still couldn't grasp, and maybe I just hadn't spent enough time, but I still couldn't grasp why this should help narrow the gap between CV scores and leaderboard. I mean, I know what they are doing, but I don't get the underlying reason why they should help. So even if it's just narrowing the gap between, it just seems totally arbitrary.
Yes,
it seems like this is just a constant which is being added as a.
Oh yeah, it is.
Bias
It is a
here.
constant, but and it's one sixth of, so it's like, starting off with equal probability in a sense. But the question really is, to my mind, why does this help narrow the gap? If somebody can explain that, I don't get that part. He just says, oh, by doing this, it will help reduce the gap. But I don't get why. And the other thing which I had not seen before, maybe you were just there, Steve, if you go back, he uses this optimizer called Aiden that I haven't heard of before. Have any of you heard of that one? There, class Aiden optimizer.
Yeah, no, I hadn't heard of it either. Yeah, so like this notebook has
I
got
haven't heard of it this either.
But yeah, so like the adding the 0.166, I saw he was doing it. I sort of skimmed the thing and saw, it was meant to give your CV score like a closer sort of representation or a closer match with the public leaderboard. But yeah, I wasn't sure then, like when you get the final score, like this is the final score coming out of this notebook, like that's the CV score. Does it mean that is this sort of, closer to what you would get on the public leaderboard, and so you can sort of see how your model's going to do? But then at the other sort of end of the scale, is it, when you compare this notebook against, like, say, Chris Diott's original ones, does it mean because of the fact you've added the 0.166 on the score you have here, you can't really compare it against the other CV scores because of the fact you've adjusted it? So like this CV score here is way better than Chris Diott's ones.
Yeah, that's it. Right. In fact, somewhere in the discussion thread that he points to, or threads, I should say, I was chasing it, and somewhere there, he seems to say, or when the he being, multitude of guys weighing in, so I don't know who is the he, but he or she. Somewhere I thought in the thread I saw that they were saying exactly what you raised, which is, the CV scores are no longer comparable. Not only that, the other thing I caught in that discussion is, actually, now I'm confused. I have to go back and look at it. But they were also saying, like, how you do the two models training. Like, you train with the lower number of votes, and then you train. I assume he's training the same model again with the larger number of votes. Am I right? Because I haven't looked at it in that much detail to see whether that's what I'm saying is right or not.
Yeah, it is. Yeah, so like you train, most of the data has like a few votes or like less than 10 votes. So yeah, like he uses that to train the model, the first part, and then in the second part, like he uses the data that has more than 10 votes, but uses the same model and just retrains that, fine tunes it.
Okay. So he just reloads the same weights and fine tunes the model with a thing. So somewhere along the way, he says that, the CV scores are, if you do this, then the CV scores are no longer comparable. So meaning you can't compare the CV here, 0.43, to whatever CV that Chris or anybody else who is not doing this is getting, is what I took away. But,
yeah, I think you're right. So like, if you don't add the 0.166 on, then your CV scores don't match anymore. And so I presume that it gives you better CV scores. But yeah, I'm not sure.
Yeah, I don't know whether it's better or it's closer correlated with the leaderboard. And, that's where, again, I'm kind of somewhat torn about this thing. And I don't understand. B, the other issue I have with it is, okay, so you're getting, and you're kind of saying, by adding that, you're saying that it gives you a better correlation, assuming it is a better correlation with the public leaderboard. The question still remains that there's yet another assumption built in, which is that the public leaderboard itself is correlated with the private leaderboard, correlated well with the private leaderboard, because the private leaderboard could be not so well correlated, in which case you would be, I would guess that you wouldn't necessarily be at an advantage by adding this. You might be at a disadvantage too, right?
Potentially, yeah, but it's just, I suppose, like, it lets you see if sort of how well your model's doing if you were to submit it.
Yeah. So that's where I was, but that's, I guess, the only indicator we have. So I don't know that, that argument. But anyway, because I didn't understand why it's supposed to help, I was just like, I wasn't sure. I think these are the two main things that are different, right? The addition of the 0.16, the Aiden optimizer, and then this two-state training. Does he do anything else which isn't done by others?
I don't think so. As far as I can see, that was it really. Yeah, so it's like the three things. It's like using the vote training data, like adding the ADAN,
Right.
whatever you call it, thing, and doing the two steps. Yeah, so like
the 0.16.
So I took his notebook, and I've improved it slightly, but just really I took it up to 10 folds instead of 5. So like that gave me a slightly better score. I've also tried.
And is he just using EG data, or is he using just EG, or is he combining the EG and spectrogram?
Well, no, it's all just like spectrogram data, but he combines the Kaggle spectrograms with spectrograms generated from that, like the new data set.
EGs.
Yeah, like the per vote thing. So like he has multiple spectrograms per EEG, and then he combines them. So like he ends up like with one image. The one image is like, it's got like 4 spectrograms on the left hand side, which are the Kaggle ones, and then 4 on the right hand side, which are generated from the EEGs. So I tried extending it, like, like in Chris Diott's picture of his banana model or whatever, where you've got like sort of the 4 horizontal ones. So I tried like taking 3 vertical ones, but so far it hasn't improved things for me.
The one thing I was thinking of doing, and is, he uses the first, right? He uses the first slice, and I was thinking of generating the data using the last slice and seeing, and then I'll probably combine it with this 10-fold thing. Does he also generate spectrograms using the same approach and save that as a data set? Do you know? When he combines the spectrograms from the Kaggle spectrograms? Or does he just use Chris Diott's spectrograms?
No, he makes his own. Like that's what the data set is. Like the data set.
So he does. He combines the EG and the spectrograms already in the data set, or does he have 2 data sets? I guess is my question.
There is a option of both, of raw and of Kaggles. The Kaggle one is the raw the raw EEGs. So you have those 3-4 options.
So like he's making spectrograms. Yeah, so his thing is like, yeah, like he does the thing here. Yeah, like he sort of, when the vote changes, he creates like a new row in the training data, and then he'll create a spectrogram for that. But he creates the spectrogram at the offset of the first
Right.
of the first vote. But yeah,
Right.
so when he actually comes to train the model, he's not using any EEGs. It's all just spectrograms. But,
okay, but what I'm saying is, in the dataset, the dataset that he creates, is that a combination of the Kaggle spectrograms and the converted EEG spectrograms?
no,
The banana
but
conversion.
no, but when he comes to use the model, in his model, he uses his own data set, which is just made from EEGs, but he combines that with the Kaggle ones.
And where does he get the Kaggle ones from?
From
Is
the
it
Kaggle.
just the Christiot ones, or does he generate them also using his own approach?
No, it's the competition data set. I'm not sure. Yeah, so I think he has a picture somewhere, or
okay, I'll check. I will look into it. Obviously, it's simple. I just was curious whether he used the chassis, because I have generated the Kaggle, regenerated the Kaggle spectrogram using the approach that he uses for the EEGs. You know what I mean by that?
No. So yeah, so like
Okay,
the Kaggle ones, he takes these four here. These are, yeah. So like the Kaggle one gives you what, 60, whatever it is. Is it? I don't know.
10 minutes, 600 seconds.
Yeah. So yeah. So like what he does is he takes just the 50-second window around the offset point. Yeah, so like these are the Kaggle ones here. He's got the 4 Kaggle ones. But yeah, like these are centered on the offset point. And then he also takes the 4, so like these 4 here, which are the ones that he's made himself per row from the EEGs. So yeah, in his model, he puts in these 8 images, is what he does. But yeah, like these 4 here have just come straight from the Kaggle competition data.
Oh, okay. Because I was actually, what I wanted to do was not, but what I'm thinking of doing will not work, because he's just using because those Kaggle spectrograms that he's using correspond, I would imagine, to the label IDs corresponding to the EEG slices, right? And what I mean by that is you're keying off of the EEG duplicates. What I was actually thinking of doing was using EEG duplicates and then also spectrogram duplicates. But I don't know of a clever way to combine them, because you would have to kind of figure out a smart way of combining them. Do you follow what I'm trying to think of? I don't even know whether it makes sense. But,
I'm not sure what you mean by duplicates.
Okay, so I just give it the term. So you see how, in case of, let's stick with EEGs, right? So for EEGs, he has found whenever the votes change, then he is retaining that row. And like you said, instead of unique EEG IDs being 17,000, you get an additional 3,000 rows. So you get 20,000 rows of EEGs, correct? where the votes are changing, right? So if I understand correctly, what he then does, if I understand our discussion correctly, then what he then does is, obviously you can, because for every single EEG, there could be cases where the votes are changing, so you have to key off of the label ID, right? So he takes those label IDs and goes to the corresponding spectrogram offset as well, and grabs, as you say, the 50 seconds or whatever, because again, your spectrogram dimensions, whether you're generating it from the EEG or from the Kaggle spectrograms, has to be of the same size if you're going to combine it. So he again takes the corresponding spectrogram offset for these 20,000 EEGs and generates, or not generates, but picks the Kaggle appropriate Kaggle spectrogram slice and combines it with the EEG spectrograms. Correct? Am I right so far?
That's right. Yeah.
Okay. So now, what I was thinking also of doing is, this is all based off of keying off of EEGs, right? EEGs converted to spectrogram and using the actual Kaggle spectrogram, right?
Yep.
Now, if you flip it around, forget the EEGs for a minute. If you just looked at Kaggle spectrograms and you submit it and you followed the same process, that is, whenever votes change, you retain that row of the Kaggle spectrograms, then you come up with a number of rows larger than the unique spectrogram IDs that you start with, right? Because it's the same phenomena as what happens on the EEG side. Your votes change based on the spectrogram rows. So for example, unique spectrogram rows are just 11,000 and odd, 11,000 and change.
But it's not spectrogram rows, it's the training set. So
yeah, it's the training set, yes.
Yeah.
Yes, it's a training set thing. But what I'm saying is, if you key off of when the votes change on spectrograms,
but yeah, so the vote changes is in the training data set. They're here. So that's got nothing to do with EEGs or spectrograms. It's independent. It's just that, yeah, like on each row, you have like an EEG ID, which refers to an EEG. You've got a spectrum ID, which refers to the spectrogram image. And then you have like the EEG offset into the EEG image or the spectrogram offset. But yeah, so like when you combine it on these votes, it doesn't matter about the spectrogram or the EEG. It's just when you combine those, like combine together rows that have the same votes, you end up left with an EEG ID and a spectrogram ID. And then, yeah, at that point, he uses the EEG offset to generate a new spectrogram, which gives you the spectrogram generated from the EEG. And then you can also take the Kaggle spectrogram at this offset on that row, and then those two things go together.
Okay, I got it. So basically what you're saying is, that's why, yeah, I was saying I need to think through that because you're keen off of changing the votes, it doesn't really matter whether you start with EEGs or with spectrogram. You'll end up with the same set of the same data, and it's just a matter of matching up the appropriate spectrogram slice with the EEG slice. Either way, because you'll get the same number of total rows regardless.
That's right, yeah.
Okay. So then the only thing I was going to try differently is this choosing the last versus the first.
Yeah.
I don't know whether that would make a difference, but I wanted.
Yeah. Oh, I've just remembered one other thing that this notebook does is he can you see like these bands across the thing? This is like his
Yes, yes. I saw that too. So he kind of introduces some augmentation, right?
He does, yeah, but he uses a bizarre one. Yeah, so like the augmentation is this XY masking. So like
Correct.
he does it 3 times, but in his one he does it very strangely. I'm not sure where his notebooks go. He does it. I've lost his notebook.
Oh, there it is.
Yeah, here's his augmentation. So like this, the first time this one here is working in the X direction, I think. Yeah, so the X direction, you're blanking out a set of values. I think it's like columns you're blanking out. So like effectively in the EEG, you're blanking out like a period of time. And then when you do it in the Y direction,
yes. When you're blanking out the columns, then blanking out frequencies, right?
Yeah. And then when you're doing rows, you're blanking out frequencies from your EEG.
Right.
But you can see here he does this like fill value thing. And so, yeah, so he's got like 8 input channels because he's got 4 spectrograms coming from the Kaggle data. And then he's got 4 spectrograms coming from his EEG generated spectrograms.
Right.
But when you blank out a column, this is the number that goes into the column. So like normally your data, because the data you've normalized, he's like normalized it to be between 0 and 1. So in the first spectrogram, he'll stick 0 into a column, but then the second one he puts 1 in, the third one he puts 2 in, and 3 in, and so like it ends up on the 8th spectrogram he's putting 7 in. So yeah, so like back in those like images.
But wouldn't that destroy the normalization thingy?
Yeah, it does. So I've changed it. So you can see here, like you can see like the vertical and the horizontal rows, the rows and columns. So yeah, so I've changed it.
Right.
Yeah, so like here's the thing again. But yeah, so rather than putting 1, 2, 3, 4, 5, 6, 7 in, I just always like set it to 0 because like that's what I was finding. It was like I was finding like when you applied like his augmentation, it was okay like on image 1 because it was just putting the blanking to 0. Here it was blanking to 1, but like by over here it was blanking to 7, and so it was completely sort of destroying all the rest of the data. And so yeah, like I've got an improvement on his score by doing that. So if you just like
I didn't quite glad you brought it up because I couldn't understand that fill value 0 to 7 random or not random choice, but how he was making the choice and why he was. I mean, I understood what he was trying to do by putting the augmentation in. And what does he do the third one? It's just combination of vertical and horizontal. Is that what he does in the params 3?
Yeah, so this one here is putting columns in, this one's putting rows in, and this one here you can see it's like it's a range between 2 and 4 and 5. That's like the height of the column, so it like puts a mixture in.
Oh, I see.
So yeah, so like you end up like with lots.
But on that one, you made that 0 as well for the last third one, keeping all the other parameters the same, but just the value to be 0.
Yeah, so you can see here, like this is the final image. In his, he would only, so like the left-hand side here, these are the 4 Kaggle images. And then the 4 middle ones here are the 4 standard EEG spectrograms. As I say, I made new ones, so I've got 12 now. But yeah, like you
what
can
is
see,
the
like,
third spec that you're using?
it's from, yeah, it hasn't really worked. Yeah, so this is Chris Diot's model. So you can see here you've got like 4 vertical spectrograms. You got the red, yellow, green, and blue. But you can see that here, these 3 middle channels, they haven't been used at all, the FZ, CZ, PZ. So yeah, what I tried doing was creating a horizontal one across there, like F7, F3. Yeah, so like these 3 channels. And so yeah, like, and then what do you call it, the heart rate thing, the EKG, I turned that into a spectrogram, which is this bottom one. So yeah, so like I made 4 more, but it hasn't.
The horizontal one works, or it doesn't?
Sorry, what?
The horizontal channels, they work?
Yeah. Well, it gives me new spectrograms, but it hasn't improved my score.
Oh, sorry. How do you generate? So you said, do you use? Sorry, I didn't get how you generate 4 new spectrograms. So you're saying because there's only one horizontal, the T3, C3, CZ, C4, T4. So do you use that?
Yeah, so you can see here, like
the horizontal one.
Yeah, so Chris Diot's picture, so one spectrogram vertical one would be FP1, F7, T3, T5, O1.
Right. The red, yellow, green, blue will give, each of those colors will give a spectrum.
Yes.
Right?
Yeah, so like here.
And then what do you add?
This is his table. Yeah, so here I add these 3. So rather than.
Oh, I see.
My screen.
So sorry, so do you stay there for a minute so I can see?
Well, you can see here, so I can make this F7, F3, FZ, F4, F8. That's one, and then right across the middle. So yeah, like it means then I've added these 3 channels that aren't used.
MZ, CZ, PZ. Right. And how do you just generate the EKG into a thing though? Into a 4th spectrogram? How do you just do it with one data point?
Oh yeah, like in that one there, I just like stick it straight into the, what do you call it? The Fourier transform. Yeah, so
you don't take any differential or anything?
No. So no, like it's just plugged straight into like the Labrusa spectrogram maker thing.
Okay. Interesting.
Yeah.
So I get the other 3 you're doing. I understand. Yeah. So you just added the 3 rows additionally, or 3 matrix entries. But the EKG one was the one that threw me off. So EKG, you just directly dump it in and say just convert that to some values.
Yeah. So like this is his code for here. He's like taking the difference between each channel. And then when he's taking the differences, then he sticks it into the spectrogram thing. Whereas like, yeah, for the EKG, you just stick it in directly. But yeah.
So without the difference, how would you get? You just say that is the actual value, because there is this K and KK thing that he does to generate, right? So you skip all that and you just directly go to Libre's piece of code and shove in the EKG value as what you work off of.
Yeah, that's right. Yeah, because like with the brain electrodes, it is like to do with the difference in like the voltage or potential or whatever, and like that's why you have to subtract them to get across. But like the EKG, it's just a time series prediction, so it's just this is it here. So it's just like sticking it straight in.
Does that they also provide EKG data here? EKG refers to the electrocardiogram, right?
Yeah, so
they do that too.
It's the 20th channel of the spectrogram data.
Oh, yes.
Of the EEG data. Yeah, so
it's dropped otherwise. and not used in anything else so far.
Yeah.
Yeah. So, did you find using it to be more effective in modeling your
No. No. So yeah, putting these bottom 4 channels in hasn't made any difference in the slightest so far.
Mhm.
But yeah.
So
But the
I
score
was
is not any
experimenting.
worse either, right? Is the
But-
score any worse?
It's like slightly worse, but it's maybe because of the fact, yeah, if you look at so this is my final image that goes into the model. So yeah, like this column here, left-hand columns, the Kaggle ones, the middle ones are the standard sort of Chris Diop spectrograms. And then this column here is my 3 extra horizontal ones and then the EKG one. So yeah, so my image now has like increased in size. Yeah, so I'm not sure if by increasing the image size, it's made it sort of harder for it to like find things within it. But it's slightly worse, but I was going to try like different models and see.
Yeah.
So I was
yeah.
trying to experiment with the B3 and trying to raise the epochs to 10 from 4. So I experimented with that, but that didn't increase the score yet. And I converted those make those spectrograms from EEG from scratch using Daniel's notebook. He had a notebook for making how to make spectrograms from EEG, and I used that to convert those 18,000, those 17,089 items that he had to let me try to get the format that I think so that was the NPY format to the native format. I converted that, I used that, but that hasn't increased the score yet. So I'll try to experiment with it, continue to experiment with it and try to see does that makes any difference. But I have yet to experiment with the spectrogram from unique EEG votes combo. So yeah, this voting combo is the one I will experiment with next, and I will see whether it can improve my score in the leaderboard as well.
It definitely improves the score for the basic ResNet and ENet B1, B0 and stuff, because I hadn't gotten with just a single ENet B1, my scores, the best scores, for a 5-fold thing were all in the 5.5, 5.7 kind of numbers with EGs. But I just this morning looked at my score with while using the duplicate, but the last duplicate, not the first duplicate. And by duplicate, I mean, picking these whenever the vote changes, but keeping the last one, not the first one. And just using the EGs, not even combining it with the spectrogram to be, to make it an apples to apples comparison. I found that it gave me like a 0.51, which was by far better than anything I've gotten. So definitely this training with, and I didn't apply the 2-state training even. So if you do the 2-state training that Steve has done with this notebook, and I like I think tenfold, like I said before, I think tenfold gives you a little bit of an improvement. And I kind of agree with also the other change that Steve has made. So I'd like to kind of stick with my last row and add the tenfolds and also add what Steve has done of, just sticking in a 0 fill value rather than the 0, 1, 2, 3, 4, 5, 6, 7 thing that he does, and see where I end up.
Yeah, like I think tenfolds
Because
is obviously going to give you better because of the fact your network's like learning on much more data. But I was only going to do that again at the end. Like at the minute, I'm still sort of searching for a better model. But I tried
And
changing. I
also
tried
I think
changing to a B1, but it didn't seem to give me any improvement over efficient net B0.
I think once you get to certain state, then they all kind of end up with almost even the same score to the second or the third decimal digit. Once you've found the sweet spot, I found no amount of ensembling or other things moves you shifting doesn't change the score. So I think the one thing I would like to stick with and try is this last row versus first row, and maybe even try to run it both ways and see whether there's a score difference.
I saw in the discussions that people are moaning that all the people at the top of the leaderboard are all ensembles already. People are moaning that they don't think ensembles add anything to the competition. But unfortunately, I ran out of GPU time this week, so I couldn't do any ensembling.
Oh, okay. Yeah, no, in fact, I finally, I think, as I said, last week I managed to get the data transferred out the week before. So I'm at least set up to use my Colab functionality, but I haven't yet run many things on Colab yet because I just was transferring the data and getting all the things set up. But fortunately, all that is done now, so I can kind of utilize both Kaggle. The good thing about the transformation, which is where I spent some of, not last week but the week prior, is the transformations are invariably done just CPU, not using GPU at all. So you can kind of, go nuts with transforming a whole bunch of stuff on Kaggle, and you don't suck up. So, you could create the data set with the first, with the last, all of this kind of stuff without consuming any GPU hours. So you can really go crazy with that on Kaggle and still conserve a lot of your compute.
Yeah, that's sort of mostly what I was doing at the end of the week was like, generating new data sets, as I say, to add in like the new spectrogram channels. What I found though was notebook output has a maximum size that you're allowed. And like when I went
19 gig.
Yeah, I was exceeding that when I went to 7 channels. Yeah, so I had to split it into 2. And like each one took about 3 hours to run, so there's a lot of waiting around for data to be generated. But as you say, it didn't take any GPU time.
Right. Yeah. So when you say split, when did that happen?
So like the guy's notebook that makes 20,000 or splits down to 20,000 rows. So he generates 20,000 spectrograms each of 4 channels. But because of the fact I added in the horizontal channels, suddenly I'm 20,000 times 7 channels as opposed to 4. And so, it was like twice as much NumPy size. And so I had to split the data in half to do it.
I see. So you had to generate 2 data sets or something, like one set and then another set. And then if you do that, then how do you determine which data set that you can just import both. But then how do you read from one of the, because you'll have to know which is in what, right? Which EEG or spectrograms is in which data set? How do you solve that?
So it creates 2 data sets, but you just load both of them in, and then you just combine them in the notebook. You just combine them into one data set in the notebook.
How do you do that? Or is there like a code that you can show how you combine 2 data sets? That's something that.
Well, it's like, like Chris Diot has made like the NumPy version of the spectrograms. So like he's got like a single NumPy file, and it just references by the spectrogram ID value. So in the case of the other guy's one, as you say, like it references on the whatever it's called, local ID. So yeah, so I just have two NumPy files, and like they're just a dictionary of like, it's like the key is the local ID and the value is the
Values they miss.
yeah, the NumPy whatever. So yeah, you just load the two files and combine the dictionaries together. So it doesn't matter that they were generated in two separate things.
So you just kind of make them into a bigger dictionary, or make them into
Yeah.
like one flat file, or
Yeah, so they're two separate NumPy files on disk, but you load them into memory into one dictionary, and then it doesn't matter that they've come from two things.
okay, got it. Got it. Got it.
I think
Yeah, so I think go ahead, Mike.
yeah, I was alluding to the fact that I think in this series of notebooks that people have people have used have written down, the TensorFlow seems to be what stuck with me. I mean, it was easier to use and modify and to change the code and to experiment with as compared to PyTorch, the HMS one. So I was thinking of that and how uh, uh, on my local, when I was trying to set it up, I had some issues trying to install both TensorFlow and PyTorch locally inside a Anaconda environment, and that had some uh, uh, some how do I put it? I had some issues in trying to deal with it, and I had to uh resolve it by trying to disable CUDA in one of them. So I was thinking about that and how those training notebooks from the TensorFlow help. So do you guys had any problem in dealing with the TensorFlow notebooks in the different environments that you guys have, or you used PyTorch once?
I haven't had any problems yet. So Chris Diott's notebook, it was TensorFlow, and then somebody came along and converted it into PyTorch. And that notebook I've just been showing you, it was a PyTorch version. It's sort of a PyTorch version of Chris Diott's, but it's added in that new, whatever it's called, add-on optimizer thing. In the past, I think I've found that, yeah, like Keras or TensorFlow do give slightly better results than PyTorch does. So I had been thinking of going back to Chris Diott's original notebook and sort of modifying it in the same ways as it does the double training and does the same augmentation, and run the TensorFlow version. But I'm not sure about that add-on optimizer. I don't know how to get that into Keras.
Yeah, I think so. Nesche was the first one that started it, and Met Ali was the one that improved upon it. And yeah, we have been using that notebooks, the PyTorch ones, that has been converted from the Christiots one. And there has been some feature plus head starter notebooks at the top with the score of 0.34 by Daniel Zakaria. And I think so that notebooks is the one that's the ensemble one. And yeah, that he has used to improve upon the Christiotis notebooks, and he has improved his process of trying to make spectrograms from EEGs. And yeah, all those small things upon that, and the 50 seconds in increments as to what Srinivasan alluded to in the last call too. So all that improvements are there in the Daniel Zakaria's one. So I will invite you guys to check that one out too.
In the past,
Yeah,
though,
I
like
stuck with PyTorch. I kind of because I get confused and in fact it's kind of I've come full circle, so to speak, because I used to be when I started off on this Kaggle and other things, I was totally on TensorFlow, and then like one PyTorch came along, I switched, and then I've never gone back. So I can follow Chris Piot's notebook and stuff, but if I were to try to code it on TensorFlow, I'd be spending all the time going back and forth to manuals rather than so I'm much more familiar or comfortable in PyTorch, so I stick to that pretty much.
I try and mix them up because I do think it sort of gives you sort of the diversity, and it's like having a whole different model. Even if you have like a model that's doing exactly the same thing, one in TensorFlow and one in PyTorch.
So I want to kind of get to that because I agree with you. I think it's a good thing to also have that. I just haven't had the time to switch. Is there a quick way that your mind used to come up to speed on Keras and usage of TensorFlow stuff, or just kind of follow the notebooks and look up the docs as necessary?
Yeah, I'm looking up the docs as necessary and using that chat GPT to come up with various form of documentations or the different type of combination of those methods. That sometimes helps, but the chat GPT's one is outdated, as I would still go to Stack Overflow all the time for information on how to use those APIs continuously and persistently in the notebooks. So that's one reason.
Yeah, because I'd like to become fluent in TensorFlow as well, which I'm not right now. So much more fluent in PyTorch, so I stick to it. But I would, for exactly the reasons that Steve is articulating, I'd like to kind of also have that under my belt. Far away from that right now. Sometimes it so happens that, especially in the models, occasionally it happens that TIM stuff, the TensorFlow has some models that PyTorch doesn't. So I think that's another reason I would like kind of develop the ability to be agnostic to choice of either of them.
On the contrary, the TIM's model have all been in PyTorch majorly. Only the few are in TensorFlow for example. So I think that one also helps. But the Kaggle models and that they have introduced the models module and has majorly all the TensorFlow models in there using the H5 or the Keras format. Yeah.
Yeah, well, Kaggle is a Google company, right? So, Kaggle is Google owned, so that's not surprising. Kaggle is owned by Google, so obviously they want to give a TensorFlow edge, if you will. All right, Rekil didn't make it this week, so I guess we'll catch up. Post the recording. But yeah, there are some, I was more interested in this notebook and because there are some new ideas here, right? Like the two-state training and this add-in thing, and then this generating the data simply by using when the votes change and stitching together the corresponding.
Yeah, as far as I can see, like this notebook here is the one that's got the highest score just with a single model. I think the other ones probably thing are all just ensembles or whatever. So like this one here has the
Yeah,
scope
that's
for
why I
killing
also
stuff.
jumped on this notebook last. Yeah, good observation. Yeah, I like the fact that this is a single thing and gives a really, I mean, almost competitive score to everybody throwing the kitchen sink and creating ensembles.
Yeah, so you could take the ideas from this one. Most of the ensembles, they're all using the same 4 other notebooks, but just different weightings of them. So you could take the ideas out of this single notebook and put it into those 4 and then get a higher score.
Yeah, you can do things like that, which are more interesting than. I think I wanted to kind of dial up the ability to get a single notebook to do really well, and then you could potentially also play with the model choices and see whether they get you anywhere. So I also find it interesting that this particular augmentation seems to work, helping quite a bit, right? So that's something else that I thought was interesting because the augmentation, I don't know how much just the augmentation contributes, but that's yet another kind of innovation or uniqueness that he has implemented in this notebook.
Yeah, like I think this augmentation is good within the whatever it's called, Alblumentation documentation or whatever. It says that this XY one is very good for spectrograms because like it does take out time and take out frequency. So I think that's why it's good. There is in the discussion, there is a whole discussion thread about people talking about what augmentations have been good for them. And yeah, like a lot of people have said, they haven't really found anything that's that good yet. But yeah, maybe sort of one that takes out, just what do you call it, cutout or whatever. It might be okay.
Yeah, there is someone, I think maybe even that the guy you were trying the notebook off with a 1D, but he did it with a 2D. I think in the 2D case, he implemented this not cut mix, but whatever the augmentation that mix up is the word I'm looking for. I think, which is creating punching holes in the data periodically, which is to me that's no different from conceptually at the conceptual level it is identical to what this guy is doing, except that just randomly creates like square or rectangular holes. In this case, the holes are like the length and the width of whatever choices that you provided. You know what I'm saying? Like in the image, the mix-up thing just creates a rectangular patch of holes. This thing kind of knocks off an entire subset of either frequency or time. So I don't know which of those two works better, but that might be something else to try too.
Yeah, like that's one thing I'd noticed about this augmentation. Like, it does the rows and the columns, but it applies it to every single spectrogram exactly the same. So I'm not sure if you applied it to like individual spectrograms, would that be any advantage? Because the Kaggle spectrograms as well, they've got like a different height. They're only like 100 rows high, as opposed to the sort of the Christiot ones, which are 128 or whatever it is. And so like it means that if you apply exactly the same rows or columns, you're taking out different frequencies in the Kaggle ones as you are to taking out in the EEG generated ones. So yeah, I was going to maybe try it. Yeah, like augmentations per spectrogram as opposed to applying exactly the same across every single one.
Interesting.
I just looked at the output of the spectrograms from unique EEG votes combo, that notebook, and he has the EEG specs of 10.58 gigs. So did you use that directly in the notebook, the HMS one, or did you manually train it?
Yeah, so like originally I used his data, the 10.5 gigs, which is 4 spectrograms, the same as Christiot's. But like then, as I say, then I added my horizontal spectrograms, and and the EKG spectrogram. So I went from 4 spectrograms per row to 8. So yeah, my data doubled from 10.5 to 21. But yeah, so far
Okay.
the best results I've got are just using his data set.
Okay.
So
Okay.
yeah, my
So
data set didn't.
what changes did you make to double it up?
No, as I say, like before, yeah. So his data set, it's just the 4 vertical spectrograms, the same as Chris Diott's banana model. And like as I say, then I took spectrograms horizontally, 3 of those.
Okay.
That's what But yeah, because I went from having 4 spectrograms, the same as he has, into having 8 spectrograms.
Okay. That's cool.
But yeah, it didn't help, or it doesn't seem to have helped.
Yeah, the 4 patterns that initially were created, I think so that by Chris, that has been propagated all through this competition.
Yeah.
Okay, so I will try with the 4 spectrograms and I think so will propagate will show you guys the results of that in the next meeting, I hope.
Yeah, I think that guy's data set's the best data set there's about at the minute. So.
Yeah, similarly, unfortunately, the guy who, the 2D version of the 1D, the same guy, the Nisha guy or whatever that Mike was mentioning as well, that Stevie had pointed to, that guy also got, but he was nowhere near in the 0.3. He was like 0.41, if I recall correctly. The one thing which he did, which I liked, but it was kind of frustrating because of the custom way that he was handling the, and we're just going to say tabular EEG raw data. The reason I liked that approach was that was the only approach which combined spectrograms from 2 sources, the Kaggle spectrogram, the EEG converted spectrogram, and the tabular EEG data. But then, he did so many custom model stuff when he was combining it that I was like, do you really need all this stuff? And obviously last week I had no time to do anything, but that's one reason I was, as I mentioned last week too, the one thing, if I had the time, and I don't know whether this week I'll have the time to fiddle with that, I just want to focus on this one. But if I had, then one other thing to potentially that I was thinking of is just using standard models versus, using all this custom RNN and this and that and resizing it, which all of it is quite complicated stuff that he does. It's somehow just to combine the raw EEG data along with the couple of spectrograms and see whether that's yet another single notebook that gives good, decent but not great results, and then use that as part of a final ensemble.
Yeah, I saw somebody else had published this week. It's a variation on Chris Diott's WaveNet model, which just uses the EEG data. It doesn't use spectrograms. And yeah, like I think it got a reasonable score. Not as good as the spectrogram ones, but like an okay one for like not processing the data so much.
Yeah, the 2D, 1D guy, I liked his approach primarily because in the 2D way, he combined a variation that I haven't seen anybody touch. I shouldn't say anybody, like you say, WaveNet did, but, but even WaveNet, it just does one thing, right? In this case, what I liked was he was combining the spectrograms from 2 sources along with the raw data.
Yeah.
In a single notebook and getting up to about 0.41, I think it was. But anyway. Alrighty, so quite a bit of, we have what until start of April or something or mid-April for the final submission?
I'm not sure, sorry. I'm actually I'm away the first 2 weeks of April, so I'm over your
You're
way.
away?
Yeah, I'm going to New York.
Oh, you're
So
headed where to? East Coast or West Coast?
out to New York and then up to
East
Oh,
Canada.
New York.
Yeah, so close to you
Canada.
or closer.
Yeah, closer. Still
Yeah.
far away.
Same country though.
Still about a 6-7 hour flight. Yeah, same country. That's true. New
So
York.
on a
Okay.
conference
Oh, but in April.
or
Okay.
on vacation?
Yeah, my son is over at university up near Toronto for a year, so
Okay.
I used to live in New York, so I'm going over to New York just to reminisce or whatever, and then head up to Canada for a week.
Oh, nice.
Oh, cool. Actually, my daughter is at Georgetown, so I'm going there in May for her graduation.
Oh, is that Washington?
Yeah, that's in DC.
Yep.
Yeah.
Yep. All right, cool.
Yeah.
Yeah,
So
let me
the
see
meeting
what
timeline is on April 1st is the team merger deadline, the entry deadline, and the April 8th is the final submission deadline.
Oh, so it's about first week. So we exactly have about a month left to the final, a little more than a month and a week. So 5 weeks maybe before we hit, and 4 weeks for Steve before it.
Yeah, so I'm away at the end
How
of
about
March.
the
So
other
after
competition? Sorry, go ahead.
yeah, I'm away at the end of March, so my deadline is whatever, the 30th of March. I'll have to stop. But yeah, the other competition I saw, they had like another release this week, another update. It's only got a couple of weeks left, but
So you're still in silver and on that one, or?
yeah, I moved up this week, so I'm 28th now. The gold medal
Oh,
places
wow.
finish at 18 though. So I think they said they got two more updates before the end.
Which competition is that?
Optiver, the stock trading thing. Yeah.
So that goes around in the background. It takes the updates.
Yeah, you're in the competition, my Hank. You're at 737.
Yeah. I was just playing around a bit. I didn't get much from that competition or that time series one. That still I'm a bit unfamiliar with that process and stuff.
Yeah, he's beaten you for this. You're at 920.
Yeah,
and,
I'm just looking it up.
What's Rackle was in it as well, wasn't he? Oh, Rackle's at 699.
Yeah, pretty good.
So yeah, but yeah, I think it finishes pretty soon. Oh, 18 days it finishes in.
Yeah, that one was the one I was struggling with on getting the what I wanted to do on the submission. One for me because I was like, I knew what I wanted to do, but I couldn't. Oh yeah, that now I recall what the problem was. I think it again, much like the current one, it just has this. If I recall correctly, it just had a single date, and it's another one of these where after much like, by the way, I never went back in the current competition and posted this question of why the combo that add up to one never really scored, the thing that we jointly tried to solve. And it kept failing on submission. So maybe I'll post it this week if I have time and ask somebody like, why does this fail? So similarly in the other competition, if you recall, there was, I think it had some nans or some such problem. And the thing is, there's no way you just have to ensure everything else is okay. I mean, there's no debugging when you submit and it just fails to the final scoring. And it hit me up on the last couple of days, and that left me very frustrated because I just had to submit or pick something where I knew it wouldn't give me a good score. That's what, because I remember even there, what you were doing was not, if I recall correctly, like the way to combine the score or to score without having to combine new data all the time, and that so there was a simplification there that I knew how to implement, but my implementation somehow was wrong, and I couldn't figure out the debugging quick enough because it worked on my CV, but then when I submitted, it would run for a while and then come back and tell me that no score, sorry, submission failed, and that's like bad.
Yeah, I think the models near the top are all ones that are doing online training. The ones who had like sort of fixed models, they're dropping off.
Yeah, which is why I think, because when the new data comes in the third month, you can no longer be good with the data that you were using to train if you're static. And I think I had to revert to static because my dynamic one kept failing. I couldn't debug it soon enough to get that working. So that now, but learned some lessons on that one. So that'll be okie dokie. Thanks for joining, Mike and Steve, and see you all next week. Hopefully some good scores and comparisons.
All right, see you next week.
Okay, guys. Take care. Bye.
Yes. Bye.